So hey everyone, welcome back to another iBuddy video, and in this video we're going to be talking about Unit 5 trigonometry, basically continuing on to our prior knowledge of trig. And in this video specifically we're going to be enhancing and basically doing application of trig ratios, which are SOH-CAH-TOA, sine, cosine, and tangent, or tan as you want to refer it. The guy that we can see on the bottom of our screen, to the left of the screen, is Hippocrates, the father of trigonometry. So if there's someone to blame, it's him, because he's the one that's making us do this trig. And this is basic trig, so if you get an understanding of this, there's a lot more to come. So it's important that you treat this as your base and you enhance your knowledge further upon. And it's also something that you find in your common life. Trigonometry is really important, especially the trig ratios. So fair warning, make sure that your calculator is in degree mode for grade 10, especially because we have not done anything about radians yet. And we don't want to do anything about radians because when radians comes, it just gets bad, right? So make sure that your calculator is in degree mode. If you don't know how to do it, you can search up on Google the exact calculator model, and that will show you how to turn into degree and radians. Now we're going to be just doing a revision on trigonometric ratios, SOH-CAH-TOA. We're going to start with questions. So basically on the right side of the screen, as we can see here, we have a question on our board, which is the top angle is the angle of the opposite of the 15 centimeter side. The opposite side, ironic, is 35 degrees. Everything is in degrees right now, no radians, and this is your 90-degree angle, and that's your adjacent. And you basically, first, before you even begin solving, make sure to label your side. So the side that's opposite to the right angle is always the hypotenuse. And the reference angle that we have, the side opposite to that reference angle is always the opposite side, and the side adjacent or next to it is always the adjacent side. So before we even begin, the first thing that you might want to do is to identify the opposite, adjacent, and hypotenuse of the right angle triangle. And remember that that this only works, the SOH-CAH-TOA, the trig ratios only work for right angle triangles. So don't try using them for an acute or an obtuse triangle. So in this question, we have to find the hypotenuse, which is labeled as x centimeters. So we're going to now step 2, which is choosing the trigonometric ratio. So depending on what we have to find, we need to choose the trigonometric ratio. So for this question, we have the opposite side, we have the angle that's for the opposite side technically, and we need to find the hypotenuse. So think in your mind, which abbreviation or which SOH-CAH-TOA, which one of these three uses opposite and hypotenuse? Yes, you guessed it right. It's sine. And just because of that, now we're going to plug in the formula. We're going to say h or x equals 15 because that's the opposite over sine 35. But before this, you can do sine 35 equals j15 over x. And then you can take the x to the other side. So you can be so sine 35x is equal to 15. X is 15 over sine 35, as we can even see here. And then when you plug in your calculator, which is in degree mode, I'm going to put my calculator out, which is in degree mode, you get your answer of 15 over sine 35. You get 26.15, which is our answer rounded to nearest hundredth or 2 decimal places. So this was just a reminder of how to do trig ratios. Now we're going to do trig ratios for another part, which is finding angles, because trig ratios can either be used to find sides, as we did in the last question, or find the angles inside a triangle when we have 2 sides. And as you may know, if you have 3 sides, you can, and it's not I'm jumping ahead right now. I was going to start talking about cosine law, but it's not important, and you're going to learn that in other lessons. So beginning with this, we can see that we have the angle opposite, or like the, okay, so this is a right angle on the side, so label your sides. Hypotenuse, adjacent, same thing as the last triangle. The reference angle is on the top, and it's labeled as x degrees, so we have to find that. So we have the bottom, which is the opposite side, which is 15 centimeters, and we have the adjacent, which is 10 centimeters. And now we're going to choose the trig ratio. So which trig ratio do you think, do the same thing as last time, which trig ratio do you think uses opposite and adjacent? Yes, you guessed it right. It's 10, because TOA, right? So opposite and adjacent. So so now, once we know it's 10, we basically use the formula, which is 10 of x is equal to 15 over 10, right? And we get that, so 15 over 10 gives us 3 over 2, which is 1.5. So now we can do x is 10 inverse, as in the previous lesson about trig ratios, you would have learned about inversing when you take the 10 to the other side. So once you 10 inverse 3 over 2, you get your answer of 56.3 or 56, depending on what you have to round to. This is the inverse sign, so ensure that you write it correctly and you round to whatever is required. Cool? Now we're going to be moving on to today's lesson. This was just a reminder of how to do trig ratios if you did not understand in the last lesson. And okay, before we begin understanding and talking about trig ratio and application of trig ratios, we have to understand the key terminology that you may encounter while answering questions based upon the trig ratios itself. So, and one key terminology is angle of elevation. So angle of elevation, or elevation itself, is when something high. When you look at elevation, it's like if you imagine what's elevated, you think something's in the sky, or like if you know Harry Potter, when they say something's elevated, it's like up in the air, right? Like the broomstick that Harry flies on, it's elevated, right? So it's mathematically, it's the angle of elevation is the angle formed between a horizontal line and the line of sight when an observer looks upward at an object above the horizontal plane. So more clearly, as we can see in this image here, so let's say the angle of elevation is basically, let's say you're looking straight at a wall, right? And you see a bird, or you see another person, as we can see in this image. So from the straight point of contact to your wall, you look up to that bird or the person. So the angle formed between the straight, so your sight, which is straight, right? The angle formed between that straight sight to your head going up to the person is your angle of elevation. Cool? This image is also explains it pretty good, because in this image, this person is looking straight at the wall, right? His view is straight. He's looking straight at the wall. And once he sees the person up, he looks up, and that angle formed between him looking straight at the wall to him looking at the person, this angle between these two different perspectives of that person is the angle of elevation. And the angle of depression mathematically is the angle that occurs when an observer looks down at an object from a higher position. It is defined as the angle between the horizontal line extending from the observer's eye and the line of sight directed towards the object below. So basically, let's say it's similar to angle of elevation. So let's say the guy on top here is looking straight. Let's say a plane is flying straight, right? And then a person from the plane has his eyesight straight. Let's say this guy is on a plane. He's looking straight. This is his view. This is his perspective. It's straight. And once he sees the guy down there, he's like, oh, there's a dog down there. Oh, there's a person down there. And once he looks down, that's his angle of depression. So his angle of depression is basically his straight eyesight and him looking. So the angle of depression is basically formed when he's looking straight and then he chooses to look down to the organism. He's like, this is his angle of depression. So between a straight line to looking down, that's his angle of depression. So something to understand here is that so you always have to ensure that you're looking at it from your straight perspective, and if you're looking at it from your straight perspective and you choose to look up to a bird, that's your angle of elevation. While if you choose to look down towards a boat, that's your angle of depression. Always from the middle, always from the straight line. Cool? Now we're going to try a word problem for this. So I'll do this word problem in here, I believe. So let's try this. From the top of a 20-meter tall lighthouse, right? So we know that this is 20 meters, right? Sorry, my manager told me that my handwriting in the last video was pretty bad, so I had to fix it. So from the top of this 20-meter tall lighthouse, which we can see here, a sailboat is sighted at an angle of depression of 40 degrees. So what is angle of depression, as I was even talking before? So we are assuming that the person is up here, let's say. So I'll make a person up here, right? So there's this person called Sam. Cool? Right? And he's looking straight. His perspective is straight, is a straight line, right? And then he's like, oh, I see a boat, right? And then he's like, I see a boat. And let's say his perspective is like this, right? And then he's like, oh, this boat's really cool as well. So I have to look down at it. So he chooses to look down at it, right? Right? So the angle that's formed here between his perspective and the position he chooses to look down at is 40 degrees. Cool? We get it? And how far? So they're asking us about this, the distance between the boat and the lighthouse. Cool? So you know what this makes? This makes a triangle. Why? Because we know, let's say this is a triangle. This is a right angle triangle. Don't mind my drawing. This is right angled. Cool? When they usually say like a building, you like assume that it's a right angle, and in this question we know that this side is this side, so 20. Cool? And now what do we see here? Do we see a pattern? Does this look like something that, okay, I'm gonna go over it with something else. Does this look like a pattern that we have learned? Yes, indeed. So we know that this 40 is the same as this angle because it forms the Z, or the alternate angles, if I'm correct. So if that angle is 40, this angle is 40. If you didn't get it, it's because of the Z pattern that we can find here. Z pattern. Cool? And once we know that, this question is really simple because you have one side, you have an angle, and you just have to find X, which is at the bottom, which is the distance between the lighthouse and the boat. So to do this, I'll zoom out a little bit. So what you're gonna do? So what trig ratio? You have SOH-CAH-TOA, right? So which trig ratio? So if this is our reference angle, let's label our sides first. We know that this is the right angle indicator. So what side is this? This is our hypotenuse. Cool. Why? Because it's opposite to the right angle, right? And if this is our reference angle, the side that's opposite to it is the opposite side. And the side that's adjacent, or like right next to it, is the adjacent side. Don't mind my handwriting. Cool? So we know that we're finding the adjacent side, right? So and we have the opposite side, right? So what trig ratio uses both opposite and adjacent? Yes, you guessed it right. It's tan, because TOA includes opposite and adjacent. So now we're going to plug in the formula to get our right answer. So tan of 40 is equal to opposite, which is 20 over x, right? And now we take tan 40 x. It's like two different things being multiplied. Tan 40x is equal to 20, right? Because you take this up here, and that basically, because it's being divided on the right side, so when you take it to the other side of the equals to sign, it gets multiplied. The opposite action happens. And after that, we say x is 20 over tan 40, right? And x is 20 divided by tan 40 is 23.8 to the nearest tenth. So x is equal to 23.8. And make sure that you always put your units. So no. I erased the question. Technical difficulties. I think it was meters. So I'm going to say meters. When you're talking about area, make sure that you put meter squared or like meter cubed, whatever it's required. But for this question, the answer is 23.8 meters rounded to the nearest tenth. Depending on what the question asks you, it can be asking you to round to the nearest hundredth, thousandth. So ensure that you know that. Now going back to our slides, we're just going to be, see exactly what we got, 23.8 centimeters. Good job, right? Now these are some word problems for you to practice after the explanation that I have given you guys. If you have any questions, ensure that you ask someone, email iBuddy, text iBuddy, we're on Instagram. So word problem 1, from the top of a cliff, 88 meters above the canyon floor, the angle of depression to the edge of the river is 37 degrees. How far away is the river from the cliff top? This is the same question that we just did. Okay. That question, I had images for you guys. So if you need to look at something physical, draw yourself an image, but understand that on a test, you're not going to have enough time. So just make a straight line or a curved line depending on what you need. The second question, okay, these two get a little challenging. So if you need help, text, right? A flagpole is on top of a building. From a point 120 meters from the foot of the building, the angles of elevation at the top and the bottom of the flagpole are 49 and 46 respectively. Find the height of the building and the flagpole. Cool? If you don't understand the question, read. Figure out. Because on a test, I'm not going to be there to help you, right? And lastly, let's read the last question. There's a pilot that's heading north to spot two fires. The fire to the east is found at an angle of depression of 47. The fire to the west is found at an angle of depression of 38. Given that the plane's elevation is 2400 meters, determine the distance between two fires. For this question, this is going to be a bit different. Because, okay, I'll give you a hint for that question. It's going to look something like... I'm not going to give you a hint. Okay, it's just going to be it's going to be divided into two right angles. That's my hint. That's all I'm going to give you. Cool? And that brings us to the end of our lesson. And I hope that you learned a lot about the applications of trig ratio. And I hope that you had fun. And if you have any questions, please make sure that you text, email someone for help, email iBuddy, because you never know what might help you, you know? And it's good to know this because this is really important. And if you continue IB or do grade 10 functions, trigonometry is never going to leave you. You're going to learn graphs about this, like sine graph, cosine graph, but for now, I'm not going to stress you out. So practice your SOH-CAH-TOA because this is really important. Anyways, see you guys in the next lesson. For me, which is about bearings. Au revoir. Bye bye, guys. Have fun.